Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at Form 3 Chemistry, and the topic for today is the mole. So, initially we talked about the mole, that is the Avogadro's constant. So, today we are going to be looking at the interconversion of mass, mole, and relative mass or molecular mass. So, and then we are going to do a few practice questions. So in an experimental work, chemists usually work with varying masses. So they cannot always use one mole of a substance because you notice in the previous lesson, we were just talking about one mole, one mole, one mole. So sometimes you can be having different masses, and masses can cause a change in the moles that are being used. So it is important to be able to know how we can convert or calculate the number of moles that we have if the mass changes. So this brings us to this formula. So number of moles is equals to mass over molar mass. So remember how we calculated the molar masses. Depending on what you have been given, you add the atomic masses if it's a compound or a molecule. So let's do some questions in regards to this so that you can be able to understand what I mean. So the first question is, what is the mass of 0.5 mole of sodium chloride? So the atomic mass of sodium is 23 and the atomic mass of chlorine is 35.5. So the formula is moles is equals to mass over molecular mass. So moles which we do not have, moles we have which is 0.25 is equals to mass which we do not have. I'm going to give it the value of x. And then the molecular mass of sodium is the same as 23 plus 35.5, which will give us 58.5. So over 58.5. So we cross multiply 58.5. We multiply also this other side, 58.5. So the value of x, so if this and this cancels, the value of x is 58.5 times 0.25. So 58.5 times 0.25 gives us 14.625. And remember, this is mass, so it is going to be grams. Next, how many moles? Now we are looking for moles are in 117 grams of sodium chloride. Once again, the atomic mass of sodium is 23 and the atomic mass of chlorine is 35.5. So formula is moles is equals to mass over molecular mass. So our moles is what we are looking for is equals to mass, which we have been given 117 grams, over the molecular mass, which we calculated, which is 23, plus 35.5, which gave us 58.5. So divide by 58.5, which will give us 2. So our moles are 2. So next, let's do more questions. So calculate the mass. So we are looking for the mass this time round of 0.4 moles of calcium. We've been given the atomic mass of calcium is 40. So it's going to be moles is equals to mass over molecular mass. So let's input what we have. So we have 0.4 moles is equals to mass, which you do not know, and molecular mass is 40. Multiply by 40. We multiply by 40. So mass is going to be 40 divided by 0.4, which gives us 16 grams. Next, calculate the number of moles. So in this case, you have been asked moles in 0.23 grams of chlorine molecule. So you've been given mass as well, 0.23. And then chlorine, we said the atomic mass is 35.5. If there are 2, you multiply by 2 or add 2, you get 71. So moles is equals to mass, the formula, over molecular mass. So moles is what we are looking for. So we have mass, which is 0.23 divided by 71, which is the molecular mass, which gives us 0.00324 moles. Let's do a few more. The last one, calculate the number of moles. So you are looking for the moles. You have been given the mass, which is 0.23 grams of dilute sulfuric acid. So we are working with dilute sulfuric acid. So we can be able to get the molecular mass of sulfuric acid, which is hydrogen, which is atomic mass 1, and there are two of them, plus sulfur, which is 32, plus oxygen, which is 16 times 4, which gives us 98. So the formula is moles is equals to mass over molecular mass. So moles is what we are looking for, is equals to mass, which is 0.23 divided by 98. So 0.23 divided by 98 will give us 0.00235 moles. So that's how we usually use the formula to calculate. I hope you've been able to understand. So that brings us to the end. See you in the next lesson.